Hi, so if you're on this lesson, that means you finished the last lesson and you're ready to move on. So we're going to start with is a couple of equations. So at the top, it says solve each equation for x. So let's start with the first one. If I wanted to solve this one for x, hopefully you can do that on your own now. If not, then stick around and keep watching. You can add 6 to both sides. You get 2x equals 16. If you divide by 2 on both sides, you find that x equals 8. So again, just to recap, we subtracted 6 from each side. We added 6 to each side, and then we divided by 2. Let's take a look at the next equation. So here, again, I want to get rid of this number first, and I want to get rid of this number last. So I'm going to add 3 to both sides. That cancels out. We get negative 3x is equal to, if I have 12 negatives and 3 positives, that leaves me with 9 negatives. Divide both sides by negative 3. We find x is a positive 3. So again, recap, I added the same number to both sides, and then I divided the same number to each side. Okay. Now let's take a look at our last problem. So I'm sure that you can see that this problem is a little bit different because there are no numbers. It's all letters, okay? So again, let's look at what we did here. I had some value in front of x, and then I was adding or subtracting some other value. I got rid of the other value, and then I divided. So let's see if maybe we can use those same steps to solve here. Because remember, variables are just taking the place of numbers, and they should be treated like numbers, okay? So if I'm subtracting b, and I want to get rid of it, well, I can do the opposite. I can add b to both sides. Now I know what you're thinking, but I don't know what c is and I don't know what b is, so how can I add those together? You're right, you cannot add those together. You have to just write b plus c. So you'll see I wrote b plus c, not c plus b, and that's because usually we like to go in alphabetical order. I bring down ax, and if I want to get rid of the a, I need to divide. So I divide this side by a, and I divide this side by a. And again, you're probably thinking, but I don't know what it's going to equal if I divide by a. And you're right, you don't know what it's going to equal. But the thing is, you do know how to write it down. B plus c, all divided by a. Okay? So we don't know exactly what x equals, but we do know how to write down what it should equal, which is b plus c, all divided by a. So this brings us to our point for today, which is this right here is what we would call a formula. Or we call this a formula because there are no numbers, it's all variables, okay? Sometimes there are numbers in formulas, but generally formulas are used when you want to find one value, okay? So let's think about this. Compare your work. Did you have to do anything differently to solve the third equation? So let's see, here I added and then I divided. I added and then I divided. I added and then I divided. So we can see that no, we didn't have to do anything differently. Okay, so let's look at this last one. Now this one says to solve for a. So if you'd like to give it a shot on your own, solving for a, go ahead and press pause and solve for a. If you'd like to go along with me, that's fine too. So solving for a. So here's a. I want to get rid of everything that's not a. So I'm not going to get rid of x yet. That has to go last because it's directly attached. So I need to get rid of the b, so I'm going to add b to both sides. Again, I don't know what b plus c equals, but I can write b plus c, and that's just as good. Okay, now I have a times x equals b plus c, and I just want to know what a is. So I need to get rid of the x, which means I need to divide both sides by x. So this gives me a equals b plus c, all divided by x. Okay, and so that's what a would equal. So what you'll see here is we actually started with the same equation in both of these problems, but we chose to solve for different variables. So when you have an equation, sometimes you're more interested in one of the letters than the other ones, and that's fine. Okay, so we're going to take a look at one longer example here and then 4 shorter examples. So the area of a rectangle is 25 inches squared, and the formula for the area is length times width. So if the width is 10 inches, they want to know what is the length. So let's think. the area is 25 inches squared, and the width is 10 inches, and the length is what we don't know. Okay? So, if I have the area equals length times width, then I can plug these in. So the area is 25 inches, so instead of area, I'm going to write 25. And the width is 10 inches, so instead of the width, I'm going to write 10. And the length is what we don't know, so I'm just going to leave it as the length. Okay, if I wanted to solve this problem, the variable's right here. I need to get it by itself, so I need to get rid of this 10 by dividing. And when I do that, I should find that the length equals 2.5. Okay, this next part says if the width is 15 inches, what is the length? So if you feel like solving this one on your own, go ahead and try it. I'm just going to list out what we know again. Area is 25 inches, the width is 15 inches, and the length is what we don't know. So I know the formula is area equals length times width. So 25 equals length times 15. If I wanted to solve this, I would divide both sides by 15. And I find the length is 25 over 15, or if I simplified this, it would be 5 over 3. And I'm going to leave it like that, 5 over 3 inches. Okay, what I'm noticing in both of these problems is that each time I divided by whatever the width was. So now what they want me to do is they want me to rearrange the formula and solve for L. So here's our formula. Area equals length times width. I want to get the L by itself. So I need to get rid of the W. Once I get rid of the W, I know that L equals the area divided by the width. And if you look back at the two problems we just did, that's exactly how we found each of our answers. So the next part says verify. Hopefully you remember that it says check. Check that the error formula solved for L will give the same results for L as having solved for L in the original formula. Okay, so they're asking us to check our two last problems that we did. So one of them was that our width was 10, and one of them was that our width was 15, and both of them had an area of 25. Okay, so we have this new formula, length equals the area over width, and I want to see if this gives me the same answer. So 25 over 10, yep, that's 2.5. That's the same answer that we had in the first one. And this one, 25 over 15, simplify it to 5 over 3, and yep, that's the same answer we got in the first one. So you'll see it doesn't matter whether we solve after plugging in or if we solve it right away for that variable because we know we're going to need it. It's still going to give us the same answer, which is why it's helpful. Because instead of sometimes when you're in the sciences or in the math, sometimes you have to do the same calculation many times. And so if you can just do it once and then plug in, it's a lot faster than having to solve it each time. Okay, so let's take a look at these next couple of problems and see what we can do. So for this first problem, we're going to solve for x. Okay, and this is a problem we should be used to a little bit. Can I distribute in this problem? Nope. Okay, can I put these two items together? No. Can I put these two items together? Nope. Do I have two variables? Yes. Which one is smaller? -5 is smaller, so that's one I want to get rid of. I want to get rid of it by doing the opposite. So I'm going to add 5x to both sides, just like that. That gives me 8x plus 4 equals 6. Okay, then I want to take away whatever is being added or subtracted. So take away 4 from each side. We get 8x is equal to 2. Now, before you freak out, remember your answer can be a fraction. There's nothing wrong with that. Divide both sides by 8, and then simplify. Okay, I know 2 goes into both of these numbers, so this becomes 1/4. X is 1/4. Okay, let's take a look at this problem. So in this problem, I see that It looks kind of like this problem, except there are no numbers here. Luckily, we can still use the exact same steps to solve this problem. So here we added the smaller variable, we took away whatever number was there, and then we divided by what was left. So I'm going to add the smaller variable, which I'm going to assume is the negative cx. So I'm going to add cx to both sides, just like that. That one cancels out. And we have ax plus cx plus b equals d. Okay, now if I wanted to do something, I could take away this b to both sides. That goes away. We're left with ax plus cx equals d minus b. Okay, I'm going to go ahead and go out of alphabetical order for this one. Okay, now I want you to look here. I need to get x by itself, but x is in two places. But we also learned how to reverse distribute. So since x is in two places, I can take the x out. So I can write this as x times a plus c. Because if I were to distribute it back in, I'd still get ax and I'd still get cx. But now it's separated a little bit. Okay, now x is being multiplied by this entire thing right here. So if I want to undo that, I need to divide by the entire thing. So I'm going to divide both sides by the entire thing. So this lets me know that x is equal to d take away b over a plus c. And that would be our answer. Okay, we got two more examples and then you're getting to your group work. So for this problem here, something I noticed is that I have fractions. Okay, and if you do not want to work with fractions, that's fine. Okay, but you do need to know how to get rid of them. So here I have a fraction of 5 on the bottom and 7 as a denominator, and if I want to get rid of it, I need to multiply the entire equation by a number that will cancel this out. Okay, so for instance, or I just need to find their common denominator. Okay, so let's look at this. We have 2/5 x plus 1/7 x equals 3. Okay, so if I was going to give these a common denominator, it would be 35, right? So I know I need something over 35 for both of these. Okay, what would I multiply by 5 to get 35? Well, 7. So I need to multiply this one by 7 over 7. And what would I multiply by 7 to get 35? Well, 5. So I need to multiply the top and the bottom by 5 on this one. And that gives me 14 over 35x plus 5 over 35x equals 3. Okay, so I got a common denominator. I'm going to add them together now. This gives me 19 over 35x equals 3. Now, when you're multiplying a variable by a fraction and you want to cancel it out, you can multiply by the reciprocal, which is the fraction flipped over, 35 over 19. When you do that, this cancels out. So we find that x is equal to 105 over 19. Okay, so how I got the 105 is I did 3 times 35 and 1 times 19, and we found 105 over 19. Okay, so now let's take a look at a problem that's very similar, but doesn't have everything that we're used to it for having. Okay, so you'll see here that we have a bunch of letters, not very many numbers, okay? But it works the exact same way. So the way I got this denominator over here was I multiplied the two denominators, right? 5 times 7 is 35. What do you think I'm going to do with these two denominators? I'm going to multiply them. So even if I don't know what they equal, I should know how to write that I'm multiplying them. So I'm going to write ax over b. Actually, I'm going to change that. I'm going to write a over bx plus c over dx. Okay, now if I want to have the denominator of bd, Okay, what would I need to multiply by b in order to get BD? Well, I'd multiply by d over d. So this becomes ADX plus, and if I wanted to multiply d to get BD, I'd have to multiply both top and bottom by b, which would give me BC over BDX equals E. Okay, so in doing that, they now have the same common denominator, so I can put these two items together. So I'm going to rewrite this. I'm going to rewrite this as AD, sorry, I wrote that wrong, AD plus BC on top of BD, X equals E. Okay, now this may look more complicated than our last fraction, but it's still just a fraction. So if I want to get rid of it, I can multiply by its reciprocal. So I'm going to multiply by BD on top of AD plus BC. When I do that, that cancels, and I do the same thing over here. So BD on top of AD plus BC. So we know that X is equal to BDE over AD plus BC. So all I did here was I multiplied the top by the top and the bottom by the bottom. And that gives us our final answer. That is what X equals. Okay, so go ahead, take a look at your problems. If you do get stuck on these problems, which can be pretty tricky, it's okay to go to the group work video right away just to check for hints or see if maybe you need the first couple steps before you can solve it, because I know some of these are a little bit trickier than we're used to.